A very good day to you all. Welcome to our presentation for today. Today I'm going to speak about queue data structure. What is queue data structure? If we define queue data structure, we can define it as a linear data structure that follows the principle of first in, first out, that is FIFO principle. What does the FIFO principle says? The FIFO principle says that the first element that has been added into the queue will be the first element to be removed from the queue. So I would like you to understand something before I continue explaining what is over there. How we work with FIFO, I can give you example. It's like for example, if you go to the bank, the first person that is arrived to the bank will be the first person to be served. That is how the FIFO principle works. So it can work like this. As you can see over there, I've got three containers that are over there that are like containers, but they are horizontal. The first one, it is reflecting in an empty queue. Then the second one is showing a queue that has got one element. Then the third one follows. Then the last one that is showing that we are now removing something from the queue. Then let's go to the next part. The next part, I would like you to understand that in programming, putting an item into the queue is called in queue. Then removing an item from a queue is called dequeue. So when we add an element or an item into a queue, it is called in queue. That is the one that is being represented on the second diagram over there and on the third diagram. For on the first diagram, it is an empty queue. Then on the second diagram, we are inserting an element, meaning that we are applying the operation that is called in queue. Then on the third diagram, we are applying again the operation that is called in queue. But on the fourth diagram, we are applying the operation that is called dequeue. Dequeue meaning that we are removing an element from a queue, right? And just know that on the second diagram, we firstly added one. Then on the second diagram, we added two. But on the fourth diagram, we removed one. We firstly inserted one, but we are going to first remove one, meaning that the first element that has been added into the queue will be the first element to be removed from the queue. Moving on. Allow me to explain about the properties of queue data structure. Queue data structure can be considered as a line of items which has the following essential properties. Number one, it has two ends that are front and rear. Then the second property, addition of a new item can only be done at rear. Then the third property, deletion of an item can only be done from the front end. Then the fifth one, the item which is added first will be deleted first. Hence, the structure is frequently called FIFO. Then the fifth one, only one item can be added. It can be added at a time. Then lastly, only one item can be deleted at a time. Those are the properties of queue data structure. I would like you to understand and not to forget something that is very, very important. Adding a new item can only be done at ray, meaning that can only be done at the back, right? Then deletion of an item can only be done from can only be done from front. Then let's move on. The basic operations that we have when we are working with Q are as follows. We have the first one that is called in Q. In Q, what does in Q represent? In Q represent adding an element at the end of the Q. But the Q, that is the second operation, the Q will be representing the removing of an element from the front of the Q. Is empty is used to check if the Q is empty. Then is full is used to check if the Q is full. Then pick is used to get the value of the front of the Q without removing it. So pick is just used just to access or getting the value, but we don't have to remove it. Now let's move on and understand how we do when we are working with Q, with the Q data structure. When we are working with Q data structure, there is something that is very important that we must know. Two variables, front and array, are used. The front keep track of the first element of the Q. Then array is used to keep track of the last element of the Q. Then initially we set the value front and array to -1. So it means that if front and array are both equal to -1, it means that the Q is empty. It means that the Q is empty. But meaning that if the Q, if we add an item into the Q, it means that the front and array will not be equal to -1. Let's move on. In Q operation, check if the Q is full. Over there we are trying to add an element, because when we say in Q operation, it means that we are trying to add an element into a Q. So the first thing is that we have to check if the Q is full, right? Because we cannot add an element in a Q that is full. Then the second part, it is that for the last element, set the value of front to 0. Increase the array index by 1. Then for the third part, you must know that we have to add the new element at the position pointed to by array. Then DQ operation. What do we do when we are working with the DQ operation? DQ, it means that we are removing an element from the stack. The first thing to do is to check if the Q is empty. Why? We cannot add an element from an empty Q. Then the second thing that we must do, it is to retain the value pointed by front. Then increase the front by index 1. For the last element, reset values of front and array by 1. It means that if you lastly remove the last element that is in the Q, it means that the value of front and array will be set to -1, representing that the Q is now empty. Then let's understand something, how Q works. Initially, front and array will be equal to -1. Just to know that the green part will be representing front, then the red part will be representing array. Then moving on, if we add an element into the first element into the Q, it means that the value of front and the value of front and the value of array will be increased by 1 or will be incremented by 1. Remember that, as I said, that front will be green and array will be red. Then moving on, if we add the second element into the queue, it means that the array will be incremented by 1. So the front will keep track of the first element, meaning that where there is the first element, that is the position where let's say where there is the first element, the front will just take the value of 0. If the front element is at position 1, it means that if the first element is at position 1, it means that the front will be equal to 1. Then we can continue adding elements into the stack. If we add the third element, that will be set at position 2. It means that the value of array will be equal to 2. If we add the third element, the value of array will be equal to 3, and so on. Over there, we have added lots of values over there. It means that the value of front is 1, then the value of array, so the value of front is 0, and the value of array is 4. That is what we have over there. Please don't get confused about the elements that are written over there in blue squares. Blue squares are representing the elements, the real elements. In the -1, 0, 0 up to 4 over there are representing the index. Index will start at 0 up to 4. Remember that when we are using arrays we start at index 0 up to n-1, where n is the size of the array. So over there it represents that the stack is the queue is full. But let's go when we want to dequeue, when we want to remove an element, when we want to remove elements from the queue. When we want to remove elements from the queue, we must first remove the first element that we firstly added. Are we together? So that is what we have to do. Let's move on. So we have removed the first element from the queue, and the value of front has been incremented. It has been incremented, meaning that the value of front will be what? Will be 1. Then if we continue removing elements, it means that the value of front will continue incrementing. Then over there, we continued incrementing the elements, meaning that over there we have remaining with only one element. The element that is that we have over there right now is now 5. And over there, just know that the value of front and the value of array are now equal. So what happens if we remove the last element? If we remove the last element, it means that the value of array and the value of front will be set to -1. That is like this. So it means that, how do we set that to -1? It means that if front becomes greater than array, then all those two values will be set to -1. Why setting to -1? It will represent that the stack is now, the queue is now empty. Then let's get and understand something that is very, very important when we are working with queue data structure in programming. I'm going to use C++ as usual, since our module requires us to use C++. When you're using C++, the first part must say hash includes IO stream using namespace std, hash define H define max, that is over there. I'm just putting the maximum size of the queue. Then I've just used my max. I declared a variable that is called q. I declared a variable that is called, I declared an array, sorry, not a variable but an array that is called q, that can hold 1000 values, right? Although we can put it any, because since over there we are working with queues, we are working with queue data structure. We know that queue data structure, it is something that is it is a data structure that is dynamic, not like arrays. Arrays are not dynamic. Arrays are static. It means that we cannot change the size of arrays we cannot change the size of arrays in at runtime. Then over there we declared two variables, front and array. Then we set them to what? To -1. Why setting them all to -1? It will be representing that it will be representing that the queue is empty. Remember, I said that if the queue is empty, the value of front and array will be equal to -1. Moving on, to check if the queue is empty. Over there, I'm now explaining what happens if the queue is empty. If the queue is empty, I would like you to understand something that is very important. I've just used a function to check if the queue is empty. My function is called isEmpty, that will return a value that is of bool data type. So bool, it means that we are returning either true or false. Then true will be representing 1, then false will be representing 0. So let's get and understand inside the function how it will be like. If the value of front will be equal to -1, it means that it will retain 1, meaning that it will retain the value that is true. Why saying true? It will say it is true that the queue is empty. If front is equal to -1, it will retain true. True will be saying that will be representing that the queue is empty. Even if I used the variable array to check the variable array, saying that if the variable array is equal to -1, it means that it will say that the queue is empty. But if front is not equal to -1, it means that it will return 0. While returning 0, it will return 0, saying that it is false, that the queue is empty. Moving on, let's check if the queue is full. How do we check if the queue is full? We use a function to check if the queue is full. When checking if the queue is full, we are now comparing the value of array to max minus 1, right? Max minus 1, max will be the maximum size of the queue. Remember that if I say max minus 1, I'm not saying that I'll be saying that as I said before, that my queue can only hold 1000 values. I declared a constant that is called max. Right, I declared a constant that is called max, that will be representing the size of the queue, and accessing the elements of the queue that I declared using arrays. It means that we can only access from position 0 up to position max minus 1. right, up to max minus 1, meaning that I'll be holding 1000 elements over there. So if it retains 1, it means that it is saying that it is true that the queue is full. But if it retains 0, it means that it is saying that it is false that the queue is full. Moving on, how do we add an element to the queue? When we want to add an element to the queue, we use an operation that I said that it is called in queue, right? An operation that is called in queue. I was previously saying that in queue means that we are adding an element into a queue. Over there I've just used a function. My function is right over there. There is a parameter, one parameter that is called value. I declared int value in my parameter list. Then inside the function I have used an if-else statement. What does the if-else statement will be doing? There is a condition that is over there. The condition is used just to check if the queue is full. If it retains 1, it means that it will be saying that it is true that the queue is full, meaning that it will display the message that says queue is full, cannot in queue the value, right? But if it retains false, it means that the queue is not full. There is an extra space in the queue that can allow us to add an element into the queue. Means that if it is not full, then we can go to the else part. Inside the else part, you must first check if front is equal to -1. If front is equal to -1, that is when we can initialize the value. Of front to 0, right? We can initialize the value of front to 0. After that, we can increment the value of ray. After incrementing the value of ray by 1, then we can add the value to the queue. The value will be stored at position ray. That is how we can do it when we want to add an element into a queue. Then moving on to remove an element from the queue. When we want to remove an element from the queue, we use the queue operation. The queue operation is the one that we use to remove an element from the queue. Over there I've used a function that will remove an element from the queue. Then let's move and understand how we will do when we want to remove an element from the queue. Over there inside the function, I must first check if the queue is empty. Why checking if the queue is empty? We cannot remove any item from an empty queue. If the queue has nothing, it means that we cannot remove an element from the queue. So in programming, it is a very good practice to do that. To first check if the queue is empty, so that you can decide to remove or not. If the queue is empty, you cannot remove, meaning that if it retains false over there, it means we can go to the else part. Then we'll be able to add. We'll be able to remove a value from the queue. That is what we can do. So whenever we remove a value from the queue, just to know that we have to increment the value of front. Why incrementing the value of front? We increment the value of front because when we remove an element from a queue, we remove the element that will be at the front. That will be at the front. Remember, it is first in, first out. The first element that has been firstly added into the queue will be the first element to be removed. That is the FIFO principle. Then let's understand something that is very important: displaying the queue elements. When displaying the queue elements, just to know that we can first check if the queue is empty, so that we cannot display nothing. So if the queue is empty, it will display the queue is empty. But if it is false, it means that we can go to the else part, then we can display the contents. Then over there I've just used a loop, a for loop. When I declared I and initialized to front, then I can be incremented up to position ray. Then I'll be decrementing my I'll be displaying my elements. So my elements, I'll be displaying my elements from the first element to the last element that I have added into the queue. Then let's go and understand about the application of queue. When the application of queues are used in CPU scheduling, and also in disk scheduling. Also again, queue are used when data is transferred synchronously between two processes. The queue is used for synchronization. For example, I/O buffers, pipes, file I/O, etc. And also queues are used when handling interrupts in real-time systems. Also again, queues are used in call center phone systems. Call center phone systems, they use a queue to hold people calling them in order. Then let's go to understand about the advantages and disadvantages of queue data structure. The first advantage that I have over there, it is that order preservation. Queue maintain the order of elements, which is essential in scenarios where sequence of processing is crucial. And also again, another advantage of using queues is that it is simple. Sometimes you can say that it is simple. The queue data structure is simple to understand and to implement. Then again, another advantage, it is resource management. They help to manage resources in various systems like CPU scheduling, network packets, and managing requests in web servers efficiently. Then let's understand about the disadvantages of using queues. The disadvantages of using queues is that there is limited access. In a queue, elements can only be accessed in a specific order, that is FIFO, first in, first out, making it difficult to retrieve elements that aren't in front. Then also again, another disadvantage is that fixed size. If we implement arrays, it will be having a fixed size sometimes. Then another disadvantage is performance overhead, then complexity in certain operations. Then, ladies and gentlemen, thank you so much for your time. Thank you so much for listening. I hope you have learned something over there. Here it comes to the end of my presentation. Have a good day.